In the last session, we studied how to solve single linear congruence. Today, let us discuss how to solve system of simultaneous linear congruences. Suppose you have system of linear congruences, say x is congruent to a1 mod n1, x is also congruent to a2 mod n2, like that. Say you have r linear congruences, x is congruent to ar mod nr. Then how to find the unique solution satisfying this? Okay, this is explained well by using the Chinese remainder theorem. It says let n1 n2 dash dash nr be positive integers such that GCD of ni nj is equal to 1 for all I not equal to j. Then the system of linear congruences, x congruent to a1 mod n1, x congruent to a2 mod n2 up to x congruent to ar mod nr has a simultaneous solution, which is unique modulo the integer product n1 n2 n3 up to nr. Okay, solution you are getting for the simultaneous system of linear congruences. You are getting a solution and it is unique. That is said by Chinese remainder theorem. Now let us understand this by solving the simple problem. Suppose you have a system of three linear congruences. Say first problem, x is congruent to 2 mod 3, x is congruent to 3 mod 5, and x is congruent to 2 mod 7. Okay, so let us solve this first. I'll explain the method how to do it. First thing is you have to check it out. These n1, n2, n3, they are relatively prime or not. Means this has to be prime with this has to be prime with this. Each pair should be relatively prime. Okay, that you have to check. If that is the case, then you can solve it. Okay, and what you have to do is, first step is calculating the value of n. What is n? This is nothing but the product n1, n2, n3 dash dash nr. In this case n1, n2, n3. So here n is 3 into 5 into 7. So it comes out to be 15 into 7, 105. Okay. Then next step is to calculate ni. Okay, ni or nk, whatever. Nk, I'll use the notation nk, capital Nk. This is nothing but n, this product n divided by ni, nk or ni. Okay, in this case n is this. Okay, product it is 105. nk is this n1, n2, n3. I hope you know this. n1, n2, n3. This is a1, a2, a3. Okay, so let us calculate first n1, that is n by n1. N is 105 divided by n1 is 3, so it is 35. Then n2 is n by n2. Here it is 105 divided by n2 is 5. So you're getting 21. n3 is n by n3, which is nothing but 105 divided by 7. So it is 15. Okay. You got n1, n2 and n3. Then what you are doing is you are rewriting the congruence relation. Linear congruences, you are writing it as you are using these ni's, ni congruent to 1 mod n1. Okay. Now I am using these ni's to write the new linear system of congruences. Okay, I'm reducing this congruences. See, these congruences have got different ai's, no? I'm just reducing, I'm rewriting them into something congruent to 1 mod 3, something congruent to 1 mod 5, like that. Okay, I'm using these ni's. By the help of this, I'm rewriting now. That is the first n1, you got capital N1, you got 35. So 35x is congruent to 1 mod 3. Similarly, 21 is congruent to 1 mod 5 and 15x is congruent to 1 mod 7. Now these are simple linear congruences and you can find the solution. Say solution to this is x1, solution to this is x2 and for this is x3. Now I'll combine them and I'll get the solution to the problem. Okay. For the first one, 35x is congruent to 1 mod 3. 33 is divisible by 3, so by adding 2 or subtracting 2 or adding 1 gives you the answer. So 35x, if you can use these two are relatively prime and you can find the universe 35 universe and do, but here since n value is very less, you can just go by trial and error method. So if I put x equal to 2, then it is 35 into 2. So that 70 minus 1 is divisible by 3. So I'm just directly writing the solution to this. I'll call it as x1. So the value of x1 is 2. Now this, if I give x as 1, then it is 21 minus 1, that is 20, which is divisible by 5. So x2 is 1. And here again, if I give x equal to 1, then it is 15 minus 1 is 14 and 7 divides 14. So x3 is 1. Now I got the solution for these linear congruences. Thus I can write this is solution of system of linear congruences, or solution to the system is x equal to, see this is very important, you are writing a1 n1. I'm combining ai's, ni's and xi by writing the summation ai, ni, xi, summation ranging from I equal to 0 to r. So this is the solution x2 plus a3 n3 x3. Okay, for this only there are only 3 congruence relations, so only till 3. What is a1? a1 is 2, and capital N1 is 35. So capital N1 is 35 and x1 is 2. Okay, I'm just substituting now. 2 into 35 into 2 plus 3 into 21 into 1, and a3 is 2 n3 is 15 and x3 is 1. So in total I'm getting 233, right? Modulo, how much it is? 105, right? So mod 105, I have to take mod of that, so that will be 23 mod 105, I guess. So it's in fact x is 223, 105 twice, so it's congruent to 23 mod 105. So the unique solution is x equal to 23. So first step is to calculate n, okay, that is nothing but product of these modular values, and then calculate ni. So this is the first step. This is the second step, is to calculate this. Then by taking these capital Ni's, rewrite the congruence relation by writing Nix is congruent to 1 mod Ni. Okay. After that, write the solution, find the solution to these congruence relations. Okay. And then combine the solution by using the summation of ai, ni, xi. Okay. Let me take one more problem. This is very easy. It's similar to previous problem. Just the values are different. Okay. Just for the understanding sake, I'm doing this. Okay. This again. First thing you have to calculate small n, which is nothing but products of this. 3 into 5 into 7, so it's 105. Then you have to calculate n1. n1 is nothing but n by n1, small n divided by small n1, so it is 105 divided by 3, so you're getting 35. n2 you are getting as 105 by 5, it is 21, and n3 is 105 by 7, so it is 15. Then you rewrite this system of equation by using these values. So the system will reduce to 35x congruent to 1 mod 3, 21x is congruent to 1 mod 5, and 15x is congruent to 1 mod 7. So find the solution to this. That gives you x1. As I mentioned, the value is 2. Here x1 is 1, and here x2 is 1, x3 is again 1. Now calculate the value, x value, which is nothing but summation I equal to 1 to r ai ni xi. In this case it is a1 plus n1 plus x1, a2 n2 x2 plus a3 n3 x3. Okay, so this is 1 into 35 into 2 plus 2 into 21 into 1 plus 3 into 15 into 1. So 70 plus 42 plus 45, 40, 157, I guess. Yeah. Now this x is 157, which is congruent to 105, right? So it comes out to be 52 mod 105. So this is the solution. I'll take up one more, which is quite different, means I'm getting larger values. Let us see how. This is the next problem. Here is this is quite challenging. In fact, the thing is, you have got these n1, n2, n3 as large values. Okay, so have to be very careful when you are answering such questions. You be careful while copying from your question paper or textbook or something like that. Okay, don't do any mistakes. Okay, first thing, when such system is given, first thing you have to check with the GCDs. Okay, GCD of n1 and n2. Here they are relatively prime, these two are relatively prime, and these are also relatively prime. That you need to check. Okay, so GCD of 11 and 29, GCD of 29 and 31, which is same as GCD of 31 and 11, they are relatively prime. So second step is to calculate the product of the modular values. So 11 into 29 into 31. Use your calculator and do the calculation. 9899. Okay, this is n. Next thing is to calculate n1, that is n by n1. n1 is 11. Okay, it comes out to be n1 is 11, so that is 899. It's 989 divided by 29. It comes out to be 341, and 3 is 319. Okay, you do the calculation. Next thing is to write NIX is congruent to 1 mod n. Okay, n1, like this. So n1 is 899. 899x is congruent to 1 mod 11. Now I have to solve. It's not so easy just by doing the trial and error method, since you have got larger values over here. Okay, if it's below 9, something like below 10, then it is quite easy. Otherwise you have to be very careful. Okay, now I'll just rewrite this. See, 899 is not divisible by 11. I'll take up the next number so that it is 900. That is also not divisible by 11. 901, again it is not. If I take one below 898, then that is also not divisible by 11. I think it's I can go for 902. What's the difference between them? It's 3, right? And this 902 is divisible by 11, I guess. 88 and 22. Yeah. So this is divisible by 11. So I'll take up 902. Adding 3x on both the sides, so 899x plus 3x is congruent to 3x mod 11. Okay, now this is congruent to 1 mod 11, so I mean 0 mod 11. Therefore I can write this comes here minus 3x congruent to 1 mod 11. Okay, now again this is negative value, so for that what I do is I'll add up or I can multiply by 4 so that I can make 12, and this is congruent to this, so I'll multiply by 4 so that this will be minus 12x congruent to 4 mod 11, and I have to make it 0 11. So if I add x to s, this becomes minus 11x, which is divisible by 11. So I'll add x to it. So that minus 12x plus x congruent to 4 plus x mod 11. Minus 11x is congruent to 0 mod 11. So this is 0 is congruent to 4 plus x mod 11. Minus x is congruent to 4 mod 11. I want positive values. So what I do is 4. If I add 7 to this, that is divisible by 11. So minus x plus 7 is congruent to 4 plus 7 mod 11. Now this is congruent to 0 mod 11. So minus x plus 7 is congruent to 0 mod 11. And now x minus 7. So I can directly write x minus x is congruent to minus 7 mod 11 and x is congruent to 7 mod 11. Therefore you got, I'm so sorry, x1 solution to this is 7. Okay. Now second equation, Nix congruent to 1 mod Ni. N2 I have to take. N2 is 341. So 341 is congruent to 1 mod 29. 341x is congruent to 1 mod 31. Now I have to solve this. Not 31 or 29. 314, 29. I'm so sorry. 29. Yeah, I have to be very careful. Okay. Now 341. If it's again you have to check with the modular values. Here it is 29. 29 does not divide 341. So if I add something to this, that which is divisible by 29, that I have to check. Okay. 7 if I add, then it is 348. I think 348. It divides by 29, I guess. So I can directly write this. I can reduce this as 7x congruent to 1 mod 29. Okay. Now I'll multiply by 4. So minus 28x is congruent to 4 mod 29. Okay. And now similar this AC I can take a positive value I have to take. So I can just rewrite the solution as x is congruent to 4 mod 29. Okay. So x2 is 4. Third equation is 319, I guess. 319, yeah, 319x is congruent to 1 mod 31. 319x is congruent to 1 mod 31. Okay, you do by yourself. Plus 9. So 9x is congruent to 1 mod 31. Then minus 27 is congruent to 3 mod 31. Then sorry, x is there. Minus 4x is congruent to 3 mod 31. 8 by 8, yeah. Minus 32x is congruent to 8 3 is 24 mod 31. So it's minus x is congruent to 24 mod 31, means x is congruent to 31. So 24 plus 7 is 31. Yeah. X is congruent to 7 mod 31. So x3 comes out to be 7. So the solution, x is nothing but a1 n1 x1 plus a2 n2 x2 a3 n3 x3. Okay. A1 is 5 into n1 is 899 into x1 is 7 plus a2 is 14 into 341 into 4 plus a3 is 15 into 319 into 7. I have an answer. Solved it already. You are going to get 84,056. In fact, this is congruent to 4,944 modulo 9,889. Yeah. So value of x you are getting is one more point. See, you can always cross check with your answers. Okay, so in the first problem you are getting x, solution to x as 23, right? Just go back to your question, put x equal to 23. 23 is congruent to 2 mod 3, right? Because 23 minus 2 is 21 and 3 divides 21. Okay, then it satisfies this. Okay, it's a unique solution. Next, again x is 23. 23 minus 3, it is 20 and it is divisible by 5, right? Next, 23 minus 2 is 21 and 7 divides 21. So x equal to 23 is correct answer. Okay. Every time if you have any doubt with your answer, whether you have done a proper calculation or not and all, just put the values over here and cross check whether it satisfies all these three equations, then your answer is correct. Okay. Next class, let us learn about Fermat's theorem. Thank you.